let's revisit unit conversions here. Remember a couple things to note. First is that we're dealing with the SI system of measurements, and it's going to make things pretty easy because all the units in the SI system are related to some standard unit or base unit by power of 10. And this power of 10 is indicated by a prefix, and this prefix is a multiplier. So we can either make a value larger than the standard unit or smaller than the standard unit by utilizing a prefix. And these prefix multipliers are always the same regardless of the standard unit. So for instance, if we're dealing with a millisecond or a millimeter, in both cases we're talking about some value that is 1/1000th of the standard unit. So a millisecond is 1/1000th of a second, and a millimeter is 1/1000th of a meter. And here's a subset of the prefix multipliers, and definitely encourage you to start memorizing these, knowing both symbol and meaning, such that a megameter is equal to 10 to the 6th meters. and that's a technology thing. These numbers should be subscript. Decimeter is equal to 1/10th of a meter, or 10 to the -1 meters. So a couple things we can also remember is that all the things we can do with units. So for instance, if I multiply two of the same units, centimeters times centimeters, I'm squaring them. Or if I divide one unit by itself, remembering from algebra that something divided by itself is always equal to 1. So this is a way we can cancel out units, by dividing them. So we're going to use that when we start dealing with this dimensional analysis. We're also going to use these units for problem solving, and almost every single problem you're going to do in this class is going to involve some sort of need to convert one unit to another. And we're going to do that using conversion factors. So for instance, we know by definition that 1 inch is equal to exactly 2.54 centimeters. So from this equality, we can write two conversion factors. We could write 1 inch over 2.54 centimeters, or we could say 2.54 centimeters over 1 inch. Now, because 2.54 centimeters equals 1 inch, this is an equality, and we can utilize this algebraically. So let's use this first. We're going to convert miles, 1.76 miles to kilometers. Now there's an easy way of doing it, and a little bit more roundabout, and I'll go about the roundabout way because of things that I've personally memorized. And so to go from miles to kilometers, we're going to have to start with mile. Mile. That's an O. Mile to kilometer. So we're going to need to convert miles to feet, and then I'm going to take feet to inches because these are all conversions that I know, and from inches to centimeters, and from centimeters to kilometers. So some things I know. I know the equality. 1 mile, update it again, 1 mile equals 5,280 feet. I know that 1 foot equals 12 inches. And I know that 1 inch equals 2.54 centimeters. What about this centimeters to kilometer thing? Well, we look here. We've got kilo equals 10 to the third, and centi equals 10 to the -2. So we can see they're different by a factor of 10 to the 5th. And so we could say 1 of the small unit, 1 centimeter, is equal to, oops, did that wrong. 1 of the large unit, 1 kilometer, is equal to a lot of the small units, 10 to the 5th centimeters. So we can put that back in, knowing we know that 1 kilometer is equal to 10 to the 5th centimeters. So now we can put this in, starting with 1.76 miles. And then we want to get rid of units of miles, so we put that on the bottom. 1 mile, because mile divided by mile is equal to 1. That's 5,280 feet. And then 1 foot, 12 inches. And feet cancel out, units of inches. And then 1 inch, 2.54 centimeters. Inches cancel out. And then finally, 10 to the 5th centimeters is equal to 1 kilometer. Units of centimeters cancel out. And hopefully put that in your calculator and you get 2.83 kilometers. Alright. So now, units, raising units to powers. And I'm just going to really quickly show you this. So supposing we wanted to convert 5.70 kiloliters to cubic inches, well, we could put 5.70 kiloliters. And to get that to cubic inches, I'm going to have to convert that to milliliters. And then from milliliters, because I know milliliter equals a centimeter cubed, convert that to centimeters cubed. And then from centimeters cubed to cubic inches. Now, one thing that we need to note is that this raising to powers. So if I've got a box that is 1 inch cubed, we know its volume is 1 inch cubed. And then for every 1 inch, we know that 1 inch is equal to 2.54 centimeters. So this 1 inch cubed is equal to 2.54 centimeters times 2.54 centimeters times 2.54 centimeters equals 2.54 centimeters cubed, or 1 inch equals, if you cube 2.54 centimeters, you end up with 16.39 centimeters cubed. So now we can utilize this equality for our conversion. Erase this real quick and we'll get to business. Alright, so 5.70 kiloliter. And then we know that there are 10 to the 6th milliliters for every 1 kiloliter. And for every 1 milliliter, there's 1 centimeter cubed. And then for every 16.39 centimeters cubed, we've got 1 inch cubed. And you put that into your calculator, and hopefully you come up with something like 3.48 times 10 to the 5th inches cubed. Alright, we'll continue on. We'll do 2 more quick problems. So the first thing I want to do is calculate the density of a neutron star in units of grams per cubic centimeter. If we know that 1 cubic meter has a mass of 5.9 times 10 to the 17th kilograms, now density is equal to unit of mass over volume. So we can take the mass, 5.9 times 17th kilogram per unit volume. Volume would be 1.0 meters cubed. And now we want to convert that to grams per centimeter cubed. So first thing we can do is get rid of this unit of kilogram. And 1 kilogram, one of the big things, is equal to 10 to the third gram. So units of kilograms cancel out. Now meter to centimeters cubed. And same thing as before. If we've got a box that's 1 meter by 1 meter by 1 meter, it's also 100 centimeter by 100 centimeter by 100 centimeter. And so we could say that 1 meter cubed is equal to 100 centimeter cubed, or 1 meter cubed is equal to 10 to the 6th cubic centimeters. So now we can put this in to our problem above, and 1 meter cubed, oops, that needs to be on the top so we can cancel out units. 1 meter cubed is 10 to the 6th centimeter cubed. And so now check our units. We've gotten rid of kilograms, we get rid of meters cubed, and we're left with units of grams per cubic centimeter. And you should come up with something like 5.9 times 10 to the 14th grams per centimeter cubed. Now, let's use this answer to solve the next problem. And the next problem is using that to find what is the mass in pounds of a 1 cubic inch chunk of a neutron star. So here's what we're going to be starting with, 1 inch cubed, and we need to know its mass. Now we know that if we've got volume and we want to convert that to mass, and this is going to be in units of pounds. To go from volume to mass, you need to use density. And remember that the density of the neutron star is 5.9 times 10 to the 14th grams per centimeter cubed. So 1 inch cubed, and to utilize this density we need to get volume into centimeters cubed, and we know that 1 cubic inch, because we did this before, is 16.39 centimeters cubed. Now this density is an equality, so that means that over 1 centimeter cubed of this neutron star is equal to 5.9 times 10 to the 14th grams. We can put that in to our problem, and that 1 centimeter cubed is 5.9 times 10 to the 14th grams. So now our units of centimeters cancel out, and we're left with a unit of mass, which is what we're trying to get to, but we need it in pounds. And one of these things I've memorized is there are about 454 grams in every 1 pound. And plug that into your calculator, and you should get something like 2.1 times 10 to the 13th pound. And if anyone knows what this means, is we're talking about 21 trillion pounds. Be quite a paperweight.